Imagine putting your hand inside a microwave while it is running. That sounds dangerous. After all, microwaves use radiation to heat your food. So here is the question. If the oven is full of microwave radiation, why does none of it escape through the door? And here is the part that surprises most people. The glass is not what stops it. Most people assume microwaves work by blasting food with some special kind of heat. They do not. Microwaves are a form of electromagnetic wave, the same family as radio waves, Wi-Fi signals, visible light, and X-rays. What separates them is simply their wavelength, the physical size of each wave. A microwave oven typically uses waves with a wavelength of about 12 centimeters. That is roughly the length of your hand. Now take a close look at your microwave door. It appears to be glass, but if you look carefully, you will see something behind it. A metal sheet, punched through with tiny holes, arranged in a fine grid, a mesh. At first glance, this seems counterintuitive. There are holes in the door. Should the radiation not simply pass straight through them? The answer comes down to one idea, and once you understand it, you will see it everywhere. Waves do not pass efficiently through openings that are much smaller than their wavelength. Think about the ocean. A large wave rolling in from the sea, maybe 10 or 20 meters long, cannot squeeze through a narrow crack in a harbor wall. The crack is simply too small. The wave hits the wall and reflects back. Microwave radiation works the same way. The wavelength is about 12 centimeters. The holes in the mesh are approximately 1 to 2 millimeters across. The holes are roughly 60 to 100 times smaller than the wavelength. To a microwave, those holes look like a solid wall. When microwave radiation hits the mesh, it reflects back into the oven. Virtually none of it passes through. The food heats up. You stay safe. That is the entire trick. Not chemistry, not special glass, not a magnetic field, just the size of the holes compared to the size of the wave. But this raises another question. If the mesh blocks waves so effectively, why can you see through the door? Because visible light has a completely different wavelength. Microwave wavelength, about 12 centimeters. Visible light wavelength, approximately 500 nanometers. That is 500 billionths of a meter. The mesh holes, at 1 to 2 millimeters, are actually thousands of times larger than a wavelength of light. To your eyes, those holes are enormous. Light passes straight through without even noticing them. So the exact same mesh behaves completely differently depending on which type of wave is trying to pass through it. To your eyes, the door is a window. You can see your food turning on the plate. To the microwaves inside, that same door is practically a solid metal wall. Nothing gets out. One object, two completely different realities, determined entirely by the relationship between the wave and the hole. Now let us talk about how the food actually gets heated. It starts with where the microwaves come from. Inside every microwave oven is a device called a magnetron. It is the engine of the whole operation. The magnetron generates the microwave radiation. And the way it does that is surprisingly elegant. Inside a magnetron, electrons are fired from a heated central rod. A powerful magnet surrounds them and bends their path into a tight spiral. As those spinning electrons pass a ring of small cavities, think of them like tiny resonant chambers. They transfer their energy into those chambers. The chambers then release that energy as microwave radiation at exactly the right frequency. It is a bit like blowing across the top of a bottle. The airflow triggers the resonance. Here, the electrons trigger the microwave frequency. Now those microwaves bounce around the metal interior and hit your food. But why does that heat it? It comes down to water and a quirk in how water molecules are built. A water molecule is one oxygen atom bonded to two hydrogen atoms. Oxygen is greedy. It pulls the shared electrons much closer to itself, giving the oxygen end a slight negative charge and leaving the hydrogen ends slightly positive. But here is the key detail. The molecule is bent. The two hydrogen atoms sit at an angle, not in a straight line. If it were straight, the charges would cancel out symmetrically. Because it is bent, they do not. One side of the molecule is negative, the other is positive. Water is a permanent electric dipole, and that polarity is exactly what microwaves exploit. The microwave radiation carries an oscillating electric field, a field that flips direction billions of times per second. Each time it flips, The water molecules in your food try to rotate and align with it. All that rapid spinning and jostling generates friction between molecules, and friction generates heat. That is it. That is how your food warms up. Not by conduction, not by a flame, but by forcing water molecules to spin billions of times a second. Which is also why dry things, a ceramic plate, a paper towel, barely heat up at all. No water molecules, nothing to spin, no heat. So the next time you stand at your microwave, here is what is really happening. A magnetron is generating microwave radiation using spiraling electrons and resonant chambers. Metal walls are bouncing those waves onto your food. Water molecules, permanently polarized, are spinning billions of times a second, turning that energy into heat. And the mesh on the door is keeping all of that radiation exactly where it belongs, because the holes are simply too small for the waves to get through. The glass is not the hero. The mesh is.